Alright, so this final review, I changed some things from last year. So the video from before was from last year, and I kind of adjusted and did some things. So this question was not from last year. I put this on this year, so I'm going to put the answer on for this one. What is the average value of a function? I need you to know that's integrating, and that we're going to integrate x squared over x plus 1. And then we're going to, from negative 5 to 1, and then we're going to divide by the difference of the bounds. So if I go 1 subtract negative 5, that's 6. To know when the degree on top is bigger, we need to divide this. So we're going to divide it, x into x squared, and subtract So the answer is x, and the remainder is 1 over x plus 1. So when I integrate this, that's what I'm going to integrate. So I have 1/6 in front. I'm going to integrate that from negative 5 to 1. I'm going to integrate x minus 1 over x plus 1. So we start with 1/6 in front, that's fine. And then integrate x, which is x squared over 2, and then 1 over x plus 1 is a logarithm. So the derivative of x plus 1 is 1. There's no adjustment needed. That's just ln x plus 1. And that's from negative 5 to 1. And then you just plug in and get your answer. So we'll plug in 1 first, subtract, and then we'll plug in negative 5. Negative 5 plus 1 is negative 4, absolute value, and we're done. All right. I'm going to do from here on. So this page on, I'm going to do with this new video. Increasing, decreasing concavity, all that good stuff. That's all derivative stuff. So we're going to take the derivative. So what I see, and then the derivative of that on top, make it equal to 0. So the only critical number is when x equals 0. So if you plug in 0 for x, the answer is 0. Nothing, you would also have to look at what makes it undefined, but nothing does. X squared plus 1 means all numbers would give you a positive value. So the only critical number is at 0. And then if I plug in a negative number, or if I plug in a positive number, you can see. So this is increasing from 0 to infinity and decreasing from negative infinity to 0. This creates a minimum. So we have a relative minimum at 0. And if you plug in 0, 0 plus 1 is 1, so ln 1. So at 0, 0, we have a minimum on the graph, and we have no max. The next part, second derivative. This would require the quotient rule. That's the bottom times the derivative of the top, and then the top times the derivative of the bottom, and then the bottom squared. If I look at the numerator and distribute, I get 2x squared plus 2 minus 4x squared, and I'm going to make that equal to 0, and I'm going to solve it. So 2 subtract 4 is negative 2x squared. I'm going to add 2x squared and subtract 2. So together, 2 subtract 4x squared is that, and I'm going to add to the other side. I'm going to subtract 2, and then I'm going to factor and solve it. So the two answers here are positive and negative 1. So if I drew a number line for positive and negative 1, the bottom is always positive. The numerator is just negative 2x squared plus 2. So when I plug in, I'm plugging into this. So if I plug in a negative value, square a negative, that's going to give me a negative number, divide by a positive. If I plug in 0, if I plug in a high positive number again, it will give me a negative answer. So where is this concave down compared to up? So negative infinity to negative 1, and 1 to infinity. Where is it concave up? From negative 1 to 1. And there's 2 points of inflection. So I'll put them over here. So at positive 1, if I plug it in, that's ln 2. The other one's what? -1. And if I plug in -1, I also get ln 2. Because -1 squared is 1 plus 1. So we have our point of inflection and concave up or down and all of it. All right, at what C value does it satisfy the mean value theorem? So mean value theorem is when A rock equals I rock. So step 1 is I'm going to plug in 0 and the answer is 0. I'm going to plug in 4 and the answer is 16 take away 4. So A rock then would be 12 take away 0. And then on the bottom would just be 4 take away 0. And then on the other side is the derivative, which is 2x minus 1, and I would solve it. So 12 divided by 4, add 1, divide by 2, and so at what C value does it satisfy it? X, we could also call it C. So when C equals 2, I rock equals A rock. All right, we have a position there. It says, what's the velocity? So I need to know what the velocity is first. So that's the derivative. So I copy, and then the hook, and then I plug in 1. So if I plug in 1 and then solve it, this is e to the 0 times 2. So the answer is the velocity is, and it's in feet per second, so 2 feet per second. So you take the velocity, plug in 1, and get 2. What's the acceleration? This is the product rule. So the first times the derivative of the second plus the second times the derivative of the first. And then again you would plug in 2. And then solve it. So I get 2e cubed plus 16e cubed. Second. And then I'm going to combine like numbers here because they both are e cubed. So 2 plus 16 is 18e cubed. All right, what's the initial speed of the object? So we're going to take the velocity and plug in 0. So if I plug in 0, I get e to the -1 times 0, which is just 0. And that would be feet per second. When is the object at rest? So we would take the velocity and make it equal to 0 and solve it. We just solved that. So an exponential is always a positive value, so it'll never be 0. So the only answer to that when it's at 0 is at 0. That's the only time it would equal 0. When is it moving to the right? So we would draw a number line here. I'll put it in the middle. It's only at 0 is the only critical number. If I plug in a negative, the answer is negative. 2 times negative. If I plug in a number that's positive, it's positive. So it's moving to the right from 0 to infinity and moving to the left from -infinity to 0. The average velocity from 1 to 2 seconds is we integrate the velocity. Now when you integrate the velocity from 1 to 2 divided by the difference of the bounds, the integration of velocity is the position. So it ends up being just the position from 1 to 2 divided by 1. So in other words, we're going to plug in 2, subtract plug in 1. So if I plug in 2, the answer is e to the 3. If I plug in 1, the answer is 1. And so the average velocity is e to the 3 minus 1, and that's feet per second. Find the average value of this. That's an integration question. Those are the bounds, and then you divide by the difference of the bounds. Now when you divide by a fraction times the reciprocal, and then this is arc tangent. So a is the square root of 1, u is the square root of 4x squared, and u prime is the derivative of 2x. It's actually perfect, so we don't need any adjustment. So this is 1 over a, which is 1 over 1, which is 1. And then arctangent, u over a, or 2x over 1, which is 2x. And then that's 0 to pi over 8. So we have 8 over pi. We plug in pi over 8 first. So 2 times pi over 8 is pi over 4. And then 0, and then we're good. All right, find the area. Also an integration question from 0 to 3. We're going to divide because the degrees are the same. That's 1. So our answer is 1, and then our remainder is 1 over x squared. This one we're going to write calculus friendly. X to the negative 2, and then we're going to integrate this. So that's just x. You add 1 to the exponent and divide from 0 to 3, and then plug in. So we have 3, and then 3 to the negative 1 over negative 1 minus, and then zeros. If you wanted to simplify it, you would be subtract 1/3. This would be 2 2/3. A Riemann sum with 3 equal subdivisions. So to find that equal base, you would subtract the bounds, divide by how many rectangles you have. So each base is 1. So you'd start with 1, and then write Riemann sum. So if you went from 0 to 3, the first rectangle is 0 to 1, so you'd plug in 1 for the height. So if I plug in 1, I get 1/2. The next thing you'd plug in 2, that's 4 over 5. Then plug in 3, that's 9 over 10. If you do a trapezoidal sum with the same thing, we already did that. So it starts with 1/2 times the base of the trapezoid. And then the first height, we have to use all of the heights. So first we plug in 0 and get 0. Then we double, plugging in 1. We already said that was 1/2. Plug in, we already said that was 4/5. And then the last height when you plug in 10. So you double the heights in the middle, not the first height and the last height. Find volume by revolving. That is a circle. And it's around y equals -2. So we have a graph of an exponential. If I plug in 0, the answer, or if I plug in -1, the answer is 0. Sorry, if I plug in -1, the answer is 1. So it kind of looks like this. That's the picture. And then y equals -2 is down here, and it's from 0 to 2. And so I want, this is what we're revolving. Oh no, sorry, we're revolving this around this line, y equals -2. So with y equals 0, so this is the area we're revolving around y equals -2. Notice there's a space here. There are 2 radii. So we're going to set this up from 0 to 2. And we're going to have a big radius, subtract a small radius. So the big radius is the top, subtract the bottom. So that's e to the x plus 1, subtract -2, or add 2. And the second one is 0, subtract -2, or just 2. And then we could multiply that out and do it. I'm going to say that we just have to set up to find the volume. You would have to FOIL this and then kind of go from there, and you could do it, but I'm not going to make you do it. So just the setup is good right there. All right, use the tangent line approximation to approximate that. So for a tangent line, we need to know x, y, and the slope. So x is pi, the y coordinate. So I need to plug in pi for cosine. So this is -1 plus pi, so that's pi minus 2, or -2 plus pi. And then the slope, I need to do the derivative of that. So the derivative of 2 cosine x is -2 sine x, and the derivative of x is 1. Again, I would plug in pi. The value of sine at pi is 0, so this is just 1. So the equation would be 1x minus pi, and then pi minus 2. If I combine like terms here, I get x, -pi plus pi. They cancel out. So it's just y equals x minus 2. And then to approximate at 2.1, you just plug 2.1 in and you get your answer. So the approximate value is 0.1. All right, diffie-q, can you draw a slope field? So I know that when you plug in 0 for y, the slopes are 0. So when y is 0, the slopes are 0. When x is 2, the slopes are 0. So I got the 0 slopes. And then we just need to go one at a time. So if I plug in -1, +1, that gives me -3 times 1, which is just -3. If I try the next one, which is at -1 and 2, that's -3 times 2, which is -6. 0 and 1 gives me -2. 0 and 2, that gives me -2 times 2, which is -4. 1, 1, that's -1 times 1, which is -1. 1, 2, that's -1 times 2. And then on the other side, I think it'll be positive slope. So 1, 2, so 3 and 1, that's 1. And 3 and 2, that's 2. So what would this look like? So on the sketch, a solution through 1, 1. So there's 1, 1 right there. So we can see which way this is going, and then turn in. So it definitely looks like a parabola-ish thing. May not be a parabola. And then we're going to solve the diffie-q. All right, I'm going to do a second video solving this diffie-q and finishing this off really soon. All right, Mr. GMath.